Hi, everyone. So my name is Alon, and I am the CTO of Aporia. Aporia is essentially a monitoring platform for machine learning models in production. And today we're going to talk about why cloud-native MLOps rocks. So what do we mean when we say cloud-native MLOps? So essentially, we're talking about a centralized machine learning platform that your team builds based on open source tools and vendors who solve specific problems. The alternative to that would be to go with a vendor or the cloud provider who just gives you an out-of-the-box full machine learning platform. Now, essentially, building your own ML platform is, of course, more work, but it enforces you to start from the problem and find the best solution. And go and talk to data scientists, machine learning engineers, product managers, and business stakeholders, and really understand what are their problems, and then build a platform using specific tools to help solve the most critical problems. Another point here is that enterprises today have a lot of different use cases for machine learning. For example, you might have a search and recommendation models, like a team with models. You also have different types of personas. You not only the model builders who are data scientists and ML engineers, you also have product managers and business stakeholders and so forth. So with such a variety of different use cases for ML and different types of personas who need to interact with those models, customization is critical. And one of the problems with out-of-the-box ML platforms is that by definition, you have less customization because it comes with a lot of with tools that solve specific problems. So how does a typical MLOps stack look like? So essentially, and this is just an example, and the point that I want to make here is that your pipeline could be completely different. But often you start from centralized data and really make sure to version the data that are used for training machine learning models. You might want to have a feature store like this common place with all of the different features the data scientist can use. Probably need a way to orchestrate trainings. So for example, that can be running training code in the cloud or things like that. After that, there's the experiments management part. So for example, you could use MLflow to track different versions of your model. So from experiments management to actually package the model, deploy to production, serve it in production. For example, you might want to have REST API where each HTTP request actually triggers the model and returns a prediction. Or in other case, that could be, for example, batch serving. And finally, you have to monitor all of that, so model monitoring. So this is super, high level, typical machine learning stack. But the point is that for your specific needs, for your organization, it might look completely different. So in order to build a really good ML platform, you need to think like a product manager, right? You need to really go out and talk to users, talk to data scientists, ML engineers, business stakeholders, and really understand their needs, and then prioritize and choose the best solution to each and every problem. So how does, from a technical perspective, an ML platform looks like? So you start, obviously, from the cloud provider. So that could be AWS, Azure, GCP. So you start from, in deploying your infrastructure on top of some kind of cloud provider. In some extreme cases, could be on-prem as well. But essentially, the second layer is infrastructure. So Kubernetes, for example, can be used for running the ML platform. And you maybe have other databases that you need, like RDS, Elasticsearch, things like that. So essentially, this is the infrastructure part. It's infrastructure where the ML platform runs on. And then on top of this infrastructure, you have the applications layer. So, for example, you can run different kinds of applications as part of your ML platform. So you can use MLflow for experiment tracking, Bento-ML for model serving, for example, and Aporia for model monitoring. But essentially, you have this application layer that serves different problems within your ML platform stack. Now, it's highly recommended to manage your infrastructure as code. So there are tools like Terraform or Pulumi for that, and your applications layer as code as well. So using GitOps, for example. And let's discuss really quickly what those two mean. So usually when you spin up infrastructure, on AWS, you go out and set up a new database. It looks something like this. So a lot of settings. Each one of these settings triggers 6,000 billion in 1 hour, and it's hard to review and make sure that it's well audited. And essentially, with infrastructure as code, you represent your infrastructure as either Terraform language or Python or JavaScript, etc. So you represent that as code that can be versioned and committed, etc. Represent your infrastructure as code, run, for example, Terraform app, Pulumi app, and then this tool will take care of spinning up all of the infrastructure. So now every change to the infrastructure, any code, any change needs to be reviewed. Anything like that is fully managed, which is a huge advantage when you manage large infrastructure, the types of ones that are necessary for ML platforms. So as for the application layer, a very common pattern is to use GitOps. So essentially, you have a Git repo with representation for all of the different applications that you need for the ML platform. And then you have a tool like Flux or Argo CD just deploys those definitions to a Kubernetes cluster, for example. So if we take a look on how would a monorepo look like for an ML platform, so you might want to have, for example, your GitHub organization and then ML platform, or you can invent a cool name for the ML platform. And then you might want to have two different directories, one for the infrastructure and another for the apps. So the infrastructure directory would contain all of the Pulumi/Terraform code to spin up all of the required resources. And the apps will have the GitOps definitions, for different applications like MLflow and things like that. So some of the common challenges that we've seen from ML platforms that we've seen that people build themselves is everything related to environments. So when we talk about environments, essentially, I mean, test, staging, production, etc. And just a tip, if you're going for Flux and GitOps and these kinds of tools, don't use Git branches. It makes things a lot messier. So that is the first quick tip. And a second quick tip is, what if your infrastructure requires what if a specific application, for example, MLflow requires a certain infrastructure component, for example, RDS or Postgres. So your application is defined probably as, Helm chart or Kubernetes resources, but the infrastructure part is managed separately, right? Because these is cloud resources. So there is a very cool tool you can try. It's called Crossplane. And essentially, it allows you to define infrastructure as Kubernetes resources. So for example, you can define a Kubernetes resource called Postgres, and then it will spin up this infrastructure in AWS. So that's an example of how such platform would look like. You have, you have a template for new models. You train them, it automatically goes to MLflow and for experiment tracking and DVC for data set versioning. You can serve your models using fast API servers, for example, serve them from MLflow packages. So that's just a high-level example, a simple example for how would a complete ML platform look like. And that's it. Thank you so much. If you have any questions, I'm available on LinkedIn, Twitter. Feel free to chat. And yeah,